Hello, Caveman Math. I know it has been a while, but my week has been hectic. There have been AP exams, and I return with another lesson in statistics. Today, I will be reviewing a few questions from my homework that will most likely help people understand the concept of finding a confidence proportion interval, right? Confidence proportion interval. All right, essentially, let's get straight into it. The confidence proportion interval formula is as follows: p hat plus or minus z score, which is your z star, times root of everything. So it's like root of everything. P hat times 1 minus p hat over the sample size, which is as n, right? Now, basically, what we do here is we're looking at this question and we're like, okay, it says in a poll of 45 shoppers, 36 state that they are influenced by price in their choice of laundry detergent. Create an 80% confidence interval for this proportion of shoppers. Now, instantly in your head, you must identify the sample size. So we have 45 as our sample size, and we have 36 out of that 45, which is the average shoppers that are influenced. So that would be our p hat, which is our average of that sample size, right? So our p hat is average sample size. Basically, what we're going to do is we're going to put 36 over 45, which equals to 0.8. And we're going to put that plus our z score, right? But we don't know our z score right now to fill in our formula. So what we're going to do is we're going to find our z score. Our z score can be found through many ways, which is actually not many ways, but two ways more specifically. One is your number in the data set minus your mean over your standard deviation, right? Or, right, if you can find in your inverse norm. So you would also do inverse norm, right? And then basically you're going to put into the percentage form of your confidence interval followed by the mean and followed by the standard deviation, which is always 1, 0, 1. So here we see an 80% confidence interval, right? What that tells us is that there is 20 more percents that need to fill this 80% to become 100%, right? And here we can see that there are 20% on both, there are 20% on both sides, right? So these would amount to 10% leading up to the confidence interval. So this would be 10% on this side, 10% on this side, and these would be just 0.1. So not 0.1, but 0, actually they are. Yeah, they're 0.1. So here, we can draw it. Inverse norm. This is how you find your z-score. Inverse norm 0.1, 0, 1. Now we're going to plug this into the calculator right here. We're going to go, all right, we have our inverse norm, right? And we plug it in, we do 0.1. Now this is a graphing calculator, not a normal scientific calculator. So that's why it has the var symbol. So now when we did this, right, we have 1.28, right? And when we have 1.28, that is our z star, 1.28. All right. Now when we have our 1.28, we're going to plug in the rest of our variables in here. We have our p hats, we have our 1, we have our p hat again, and then we have our sample size, which is 45. Right? Now, essentially, we're going to focus on this side of the equation first. We're going to solve this. So if you plug this entire thing in a calculator, right, all of this is under the radical, excluding the 1.28, which is times by the radical. When you calculate this, come back. All right, guys, after plugging in the first part of the equation into the calculator, we get 0.076, right? And essentially what you do with that now is you're going to plus that with 0.076. I'm just going to plug in the original number to, oh no, not the original number, sorry, 0.08, right? And what you get from that is 0.88 rounded. So our first answer is 0.88, right? Now, right, what I'm going to do is I'm going to grab the same number that I see here, right, which is this decimal. Actually, not this decimal. I'm going to grab this decimal, copy as plain text. I'm going to paste it again here. I hope I can paste it. Seems like I can't. Alright, I'm going to paste it. Be right back. Alright guys, I pasted the answer to this and then I subtracted it by 0.8 and I got the other side of the equation, which is 0.72. Now we found our confidence interval for 80% of the proportion of shoppers who would say that they are influenced by price. All right, now going on to the next problem, we see a sample size of 250 students who are interviewed, of which 200 prefer tennis to racquetball. And we find that 85% and with a 99% confidence interval for the proportion of students who prefer tennis over racquetball. Now we need to determine which interval is more precise. Now, essentially what we do with this is we have to find the z-score for both of these and compare their intervals with an 85 interval and a 99 interval. This is a two-step process. Now, first, we need to see, okay, what's 200 over 250, because we need to find our p hat. I mean, do we? I mean, yeah, kind of we do. So this would just be 0.8 again, I think. Yeah, it is. All right. Now, what we do here is we look at the 250 students, right? And we have the 200 students here. Now we need to see, okay, 85. Let's do 85 first. We have 85%. Right, so what is 80? How much do we need until we get to 100% from 85? So 85 minus 100. Yeah, all right. 85 minus 100 is 15, and 15 divided by 2 is 7.5. Now 7.5% is just, so let's say 7.5 over 100. It is 0.075. So we can just do inverse norm, right? 0.075 and 0.1. Okay, now we need to actually get the z-score for this. All right, be right back. All right, guys, I plugged this into my graphing calculator, and the z-score for 85% is 1.444, I think. Yeah, 44. Yeah, it's on the calculator it says 1.439, and I'm assuming that's rounded to 1.44, right? And now I think we can even find out which one is more precise from the z-score alone, but let's just keep solving. So a 99% confidence interval would actually be 0.005, I believe. Yeah, so inverse norm, we have 0.005, and we have a 0, and then we have a mean of 1, right? And then we're going to plug this in and find the z-score for 99%. Be right back. All right, guys, the z-score for 99% is 2.576. Now, with these z-scores, we can see that this one is more and this one is less. All right, well, we need to kind of find out the intervals, right? But instantly when I'm seeing this, I always see the smaller z-score as the one that is more precise normally, right? Because, well, with a smaller z-score, that means that it's naturally going to have a lower answer, and that lower answer plus or minus is still going to be lower than the one that has a higher answer, which means that the lower one is more narrow and more precise. But anyways, you have to prove why you know this by solving it in the exact way that we did above. All right, let's get it. 0.8 over, what is that, 250? Okay. And this one, which is what? Our z-score is 2.576. Wait, no, it's not. Because this is 6. This can be 578, 58. This is 258. Okay. Now we just plug this in. We go 0.8 plus or minus 2.58. Right, and then we do times, and then what is that? A root, which is 0.8, 1 minus 0.8. That's very borderline. I'm sorry for drawing it like this. All right, now when you plus or minus this, it's essentially going to give you a confidence interval of 0.73, 0.87, right? And for this one, it's going to give you a confidence interval of 0.76 and 0.84, right? Obviously, seeing this, you can tell that it is narrower because the range is smaller. See, if you subtract 84 from 74 in my caveman math head, brother, you see 84 minus 76 is 9, right? And we have 87 minus 73, which is 14. So obviously the difference between these numbers is more here, so there's a bigger range, and the difference between these numbers is less. So this means that this is more precise. More precise. All right, I think I have shown enough. I do not want to reach the 15-minute mark. I appreciate for you guys listening to this and finding out how to solve these variations of confidence proportion interval. This has been Caveman Math. Goodbye, brothers and sisters of internet. Tune in for next video. Bye bye.